Okay, good morning, everyone. This is Randy at Central Region Headquarters. Thanks for joining this week's guest speaker series presentation. Today we have Eric Carothers from Valparaiso University, who'll be graduating next May with his BS in meteorology. And this summer he has been a summer volunteer at Louisville and is going to present today on a Lexington temperature study. So thanks, Eric, very much for your willingness to share your material with us today. Appreciate you coming on, and go ahead and take it away.
Thank you, Randy. As Randy said, my name is Eric Carothers, and I am a senior here at Valparaiso University, where I'm getting my undergraduate meteorology degree. I also am on the cross-country and track teams here, so I am very involved around campus. And then this past summer, I was down in Louisville, being a summer student volunteer, and they had me working on a Lexington temperature study. So I'm going to start this presentation off with some of the motivation behind the study, and then I'll go into a little bit of the background and some of the data that I used and where I got it from, the methods that I used to analyze the data, some of the results that came out of it, and then the conclusions that I was able to come to. So for the motivation, Louisville had several social media and media inquiries and comments about a temperature difference between the Lexington ASOS at Bluegrass Airport and the Fayette County Mesonet. The ASOS thermometer was replaced on multiple occasions over the last decade due to these social media and media inquiries. And so we just wanted to investigate and look at the temperature. I ended up looking at the temperatures from 3 sites: the Lexington ASOS there at the airport, the Fayette County Mesonet site, and the Climate Reference Network site in Versailles, Kentucky, which was just a few miles away. So it was another easy site to compare data with and just gave me another thing to look at. So for those of you who are not from the Kentucky area, Lexington is in the far eastern part of Louisville's CWA. It's directly south of Cincinnati and pretty much directly east of Louisville, a little bit south. But this is just kind of the region where Lexington is, just to give you some background on that. So within Lexington, the 3 sites that I looked at, going from left to right here, the CRN site, just north of the city of Versailles. The elevation of that site is 890 feet, which this could come into play a little bit later. And then just over 8 miles away is the ASOS at Bluegrass Airport, as I mentioned, with the elevation of 955 feet. And then just under 6 miles southeast of that is the Mesonet site, which is located at 1,044 feet of elevation. And as you can see, the ASOS is located just outside of Lexington's city boundaries, and it's outside of the urban heat island that Lexington creates. So that is something to note there. And then this is just a satellite view, the same image, satellite view, so you can kind of see what's around each site. And then we'll go close up into each site. So the ASOS, before September 29th, 2009, was located here at Bluegrass Airport on the northeast side of the terminals. And after September 29th, 2009, the airport was reconfigured and the ASOS was moved about a half a mile southwest. So I've got the former ASOS location pinned there. It would now be on a runway, so that is obvious reasons as to why it had to be moved. And it's now located much closer to the main runway and directly east of all of the terminals and concrete of the airport. So the Mesonet site is located here in a field at the horticulture farm, sponsored by the University of Kentucky, or run by the University of Kentucky, rather. And as you can see, it's in a fairly residential area, although the Mesonet itself is fairly well centered within the farm, so it's not close to any of the houses or buildings around it. And it's located directly adjacent to an apple orchard there. I believe you can see that fairly well in the satellite image. And Then to the south and southwest of the mesonet site, there is a lot of open fields which are of note, and I will come back to in later slides. The CRN site is located in a farmer's field with absolutely nothing surrounding it. So there is a home there to the west of it, but that does not have any large impacts on it. Overall, it is in a very open area. So now I want to circle back to why the ASOS was moved. In 2006, Comair Flight 5191 crashed at the airport after using the incorrect runway for takeoff. As you can see in the image there on the right, the path that the plane was supposed to take is the blue arrow. So it was supposed to use the long main runway. However, an error during taxi resulted in them attempting to take off from the short runway, and they crashed just off the end of the runway, resulting in the death of all except one on board. So with this reconfiguration of the runways at the Lexington airport, the ASOS was moved just over a half a mile with an elevation decrease of 10 feet. And so now I want to go into how the official temperatures are recorded at each site. So the ASOS reads the temperature every 10 seconds, and then every minute it averages the 6 most recent 10-second temperature readings. And also every minute it takes the 5 most recent single-minute averages and computes a 5-minute average. And this 5-minute average is what is on all official records and all data that is posted to websites and social media and things like that. The mesonet reads the temperature every 3 seconds and then computes an average temperature every 5 minutes. And this 5-minute average is also what they use for all of their data and official records. And the CRN site operates in a very similar manner to the mesonet, reading the temperature every 3 seconds and computing an average every 5 minutes. And something to note here is that all observations are recorded in Fahrenheit to the 10th of a degree. So any observations that you see recorded in Celsius or any data that you see recorded in Celsius has been converted from Fahrenheit to Celsius. Another thing I want to brush on is the thermometer tolerances of each thermometer at each site. So for the ASOS, tolerance checks are required every 180 days, but they're often done every 90 days with preventative maintenance checks. And the sling psychrometer that you see in the bottom right corner there is what is used to check the tolerance. And one of the interesting things that I found is that there are actually two different tolerance standards that the ASOS is supposed to be within, depending on which guide you are looking at. The ASOS manufacturer's standards requires the ASOS to be within plus or minus 1 degree Fahrenheit of the psychrometer, while the ASOS user's guide is required to be within plus or minus 1.8 degrees Fahrenheit, which coincidentally lines up with exactly plus or minus 1.0 degrees Celsius of the psychrometer. And this is interesting because the two tolerances are not the same. So each ASOS could be calibrated slightly differently depending on which guide was used to check the tolerance of the ASOS. And the temperature sensor is recalibrated anytime that it falls outside of the tolerance range. For the mesonet, tolerance checks are not required to my knowledge. However, the mesonet has 3 separate thermometers that get averaged to get the official temperature reading. And all 3 of these thermometers are required to be within plus or minus 0.1 degree Fahrenheit of each other. So that is a much smaller range for tolerance. And this kind of acts as a quality control so that a bad thermometer can quickly be identified and replaced if it is reading more than 0.1 degree Fahrenheit different than any of the other 2 thermometers. And the CRN site also does not have required maintenance checks, but it also has 3 thermometers just like the mesonet that are averaged to get the official temperature reading. I do not know if those 3 thermometers are required to be within plus or minus 0.1 of each other, but I would guess that they do have some kind of tolerance that they are required to be within. So for this research, I took the daily high and low temperature data from January of 2017, so the start of 2017, through the end of this past June, June of 2022. And all temperatures, I rounded them to the nearest whole degree. And then I got my data for the ASOS from the National Weather Service archives. For the Mesonet, I pulled that from their website. They have an archive on there. And then the CRN also has an archive of all temperature data. So I took these high and low temperatures and I put them into the spreadsheet that you see here on the right. And I calculated the difference, the temperature difference between the high and low temperatures between the ASOS and the Mesonet, the ASOS and the CRN, and the Mesonet and the CRN. And then I went through and I highlighted all temperature differences that were the same. So that's the highlighting you see in those middle 3 columns. And then I also took the wind direction and the wind speed, and all the highlighting that you see in those columns, that was just for my own eyes, for my ease, so I could analyze the data a little easier and see patterns and trends in wind direction. And so some of the results that came out of this, I then created charts and graphs of all of this data, and the results that came out of this were very interesting. So this first slide here is looking at the high temperature difference between the ASOS and the Mesonet. So I think that the graph there on the right best shows how the ASOS and the Mesonet line up. And the ASOS almost always is reading warmer than the Mesonet, as you can see by the trend line. But the interesting thing is the variation by season. During the summer, you can see that there's a very obvious greater temperature difference than there is during the winter. And one thing to note here is that the ASOS thermometer was replaced on both 12820 and 31422. However, tolerance checks were done regularly as required, both before and after these replacement dates. Therefore, the thermometers must have been reading within tolerance both before and after the replacements, both of the replacements. And so the data between 12820 and 31422, although it looks like it's reading much more similar to the Mesonet and much differently than it was before, it still had to be within tolerance. So it was still within that plus or minus 1 degree Fahrenheit or plus or minus 1.8 degree Fahrenheit, depending on which guide was used for the tolerance checks. So moving on and looking at the correlation between the high temperatures between the ASOS and the CRN sites, you can see a very similar pattern between the ASOS and the CRN. The ASOS is typically reading warmer than the CRN, and you can still see that shift based on the season, with the summer difference being greater than the winter difference. And the same sort of thing happens when the ASOS thermometer was replaced on those 2 dates. So now we'll look at the difference between the Mesonet and the CRN high temperatures. And as you can see by the trend line, they are very similar in high temperature readings. So the high temperatures between the Mesonet and the CRN are very similar. Obviously, there is a lot of noise there, so any given day you could see a decent temperature difference, but overall it balances out to leave them very similar. So now we'll look at the low temperatures between the ASOS and the Mesonet. As you can see, before the thermometer was replaced on 12820, the ASOS and the Mesonet were reading very similar low temperatures, which leads me to believe that the thermometer was not the issue with the high temperature difference, because the low temperature difference was almost 0. And as you can see on the right hand side, or on the left hand side there with the graph, if you were to draw a bell curve on that, the bell curve would be centered almost exactly on 0. So there was very little temperature difference there before the thermometer was replaced. And a similar thing can be seen between the ASOS and the CRN, although the ASOS did read a little warmer than the CRN at night, and the Mesonet also reads slightly warmer than the CRN at night, likely because the CRN is in such an open area. It can mix out any daytime heating better than the Mesonet or the ASOS. So a summary of these results, a quick summary of these results. The ASOS highs are regularly 1 to 3 degrees Fahrenheit warmer than both the Mesonet and the CRN sites. And as I noted on the graphs, a larger spread is observed in the summer than in the winter. Lows are generally even between the ASOS and the Mesonet, with the CRN being slightly cooler than both. Although it should be noted that the ASOS can regularly get cooler than the Mesonet at night, which indicates that the thermometer was reading properly before it was replaced and reading properly in between the two replacement dates. And these results, in my opinion, are to be expected based on the different microclimates that each site is in. So a microclimate is a local set of atmospheric conditions that differ from those in surrounding areas, and these can be very small or very large. And so although the ASOS, as noted back on the maps, is only a few miles away from both the Mesonet and the CRN site, the areas surrounding each site are very different. The ASOS is located there at Bluegrass Airport and is subject to a heat island from the airport. The Fayette County Mesonet is in a field near trees and plants. It's right next to the orchard, as I mentioned, and away from any roads or buildings. And it also has the big open area to its southwest. And the CRN site is also in a field, but there are no trees or plants present. As you saw in the satellite image, it is in a farmer's field, so there is nothing around. And that includes buildings and roads. There are not any of those nearby that would have an impact on the CRN site. So why is the ASOS warmer during the day? Well, it's subject to a heat island from the airport. And a heat island forms when buildings, roads, and other infrastructure absorb heat and re-emit it into the air. This warms the surrounding areas more than they might otherwise be warmed. And this is especially prevalent under sunny conditions. Cloud cover will inhibit the strength of a heat island more so than a sunny day would. And then winds can act to move this warm air from directly over the heat island source into nearby areas, which is what happens at the airport. So the strength of the heat island at the airport on any given day is subject to cloud cover and wind direction, as I just mentioned. And the temperature difference actually grows when the wind heading is between 50 degrees and 200 degrees. And the largest differences between the ASOS and either the Mesonet or the CRN site generally occur between 65 degrees and 135 degrees. And if we take these two headings, 65 and 135 degrees, and plot them on that map from earlier, you can see that these wind headings are coming directly from the airport, which just helps to prove that the heat island is what is causing the warmer daytime temperatures and why the nighttime temperatures are so similar between the two, or between the three sites, but especially between the ASOS and the Mesonet. And then another thing to note is that when the wind is coming from the south or the southwest, as I mentioned earlier, the Mesonet has the large open field to its southwest that you can just start to see there at the bottom of the screen. And when the wind is coming from this direction, the Mesonet can actually get cooler and experience, it might experience some heat island effects from the neighborhoods around it, but when the wind blows from this direction, there is nothing for heat island to affect the Mesonet site. So that is another thing to note in the temperature difference. And then I also did some research and found some supporting studies for all of this data. So an older study from 1978 at Miami International Airport found that larger planes in a microclimate caused a rise in temperatures at the Miami airport. And then a later study, which was looking at temperature differences between ASOS sites and CRN sites, found that the temperature differences can be expected between the two due to sighting differences in the instruments, because the ASOSs are required to be at airports for aviation purposes, and the CRN sites can be located in an open field as the one in Versailles is. And then I also found a master's thesis from 2014 that was comparing the Lexington ASOS and the Louisville ASOS to the surrounding Kentucky mesonet sites. And something to note in this study is that the Lexington data came from before the ASOS was moved in 2009. And their findings were that both Lexington and Louisville were found to be warmer than the mesonet sites due to what they called artificial structures and microclimate. So that just kind of shows that the issue of the Lexington ASOS and the Louisville ASOS actually being warmer than the mesonet sites and CRN sites has been around even from the time before the Lexington ASOS was moved. And then the most recent study, actually from this year, from 2022, was looking at microclimates in airports, and it found that almost all airports used in the study were found to have their own microclimates, which is something to note because each airport was then impacted by that microclimate and was showing temperature differences and climate differences from the surrounding areas. And so looking forward, I'm looking to present this study to interested parties in the Fayette County vicinity. So this includes emergency management partners, local media, both print and broadcast, and weather spotters, and anybody else who might be interested or could benefit from hearing about this research. And then I would also like to create some social media graphics to spread the word about how microclimates affect temperature and on small scales, so just within a local area. And I would just create this to just spread the word to the public and to anybody else who might have questions about this. And that's all I have. So if you have any questions, my email is there. Feel free to contact me, and then I will also take questions at this time. Thank you very much.